Hello students, in class 10 science we already discussed about work, that definition of work and its types. We all know we have three different type of work: positive, negative and zero work. In positive work I told you that force and displacement are in same direction. In negative work, force and displacement are in opposite direction, and in zero work, if force and displacement both are present, then they are perpendicular to each other. Now today we will discuss about a concept that is called energy. So you all know what energy is. If I say, if a person is doing some work, he is doing the work by the expense of energy he have. Or simply we can say that if we have energy, then only we can do the work. So they are very common term. We cannot differentiate the two with the exact barrier. If we have energy, then we can do the work, or if work is happened, then energy must be consumed or dissipated. So they are very similar terms, not exactly similar, but somehow they appears to be similar. If I have lot of energy, I can do lot of work. If I have less energy, I am tired, I cannot do that much of work. So they are equivalent terms, or we can say there must be a relation between work and energy. In this chapter, work and energy are equivalent. They have same SI unit. Only the basic difference is that if we have energy, then we obtain the work. It means energy is something that is an input, and what we obtain, that is output, is work. So we have a very general definition of energy that says energy is defined as the capacity to do work. Like work, this is also a scalar quantity. SI unit of energy is joule. This is SI unit of both work as well as energy. CGS unit of energy is urge. This is CGS unit, this is SI unit. We all know that what is SI unit, what is CGS unit, already discussed in class 9th. Now we have various form of energy, but here we will study about mechanical energy. Mechanical energy. So the capacity, this can be defined as the capacity of a body for doing mechanical work is known as mechanical energy. We categorize it into two parts. This mechanical energy can be further classified into two parts: You are familiar with the two terms, kinetic energy and potential energy. Now we will discuss about the two forms of energy, kinetic energy and potential energy, one by one, and then we will also discover that is there any relation that exists between kinetic and potential energy. So first we will discuss about kinetic energy. As per definition, the energy possessed by a body by virtue of its motion is called kinetic energy. The energy that is present in a body when it is in motion. Very simple definition. I will make it very simple, that if a body is in motion, it is moving, then whatever energy it have, that is kinetic energy. For example, if a truck is moving and hit a car, why it will hit a car? Because the truck have that energy, and that energy is due to the motion of the truck, and that is kinetic energy. If truck is moving very slowly, again hit the car, the energy imparted by the truck to the car is very less. Why? Because the energy in the truck is very less, because its velocity is very small. So the very simple definition of kinetic energy, if a body is in motion, if body is moving, then it possesses energy, and that energy is called kinetic energy. We will derive an expression for kinetic energy, a mathematical relation for kinetic energy. For that, consider this is a flat surface and a block lying on it. Mass of the block is m, and if external force F is applied on it, and due to this force, initially this block is in rest, so its initial velocity will be 0. And if we apply a force on this block, due to this force, this block acquires certain velocity. Mass will remain same, but its velocity changes to v. Let the displacement is s while this change in velocity takes place. If we have a football in a ground at rest, if you apply a force by kicking it, that football must acquire a velocity. That's what I'm saying, that block initially at rest, if you'll apply a force, it acquires a certain velocity, and if acquires a velocity, it means it must covers some distance also. So by definition of work done, as I told you, that work done is equals to force into displacement. Also we know, we studied in class 9th, that force is equals to mass into acceleration. So just substitute this value. This work done is equals to force into displacement as per our definition, and we know that force is equals to mass into acceleration. Okay, student, just remember one concept from class 9th, that if body changes its velocity, it must have certain acceleration. If a force is applied, then we must have some acceleration. So let acceleration of this body is A. Remember the third equation of motion that says v square is equals to u square plus 2as. V is final velocity, u is initial velocity, a is acceleration in the body, and s is displacement. I can write it as 2as is equals to v square minus u square, or s is equals to v square minus u square upon 2a. So this is the value of displacement. If I substitute this value of displacement here, then it becomes W is equals to work is equals to force. Instead of displacement S, I will write v square minus u square upon 2a. And for this F, I will use this value. So this work done becomes, instead of F, m into a, v square minus u square upon 2a. A and a will get cancelled. Now we have mv square minus mu square upon 2. Divide the two terms by this mv square by 2 and mu square by 2. So it becomes half mv square minus half mu square. But I told you that initially u will be equals to 0. So just substitute the value and it becomes half mv square. This is the work done. I told you that this work done is equals to energy stored in the body, and this work done is very much equals to our kinetic energy. So expression for kinetic energy is half mv square.